Hey, what's up, pre-calculus? I know you guys had the PSAT today. Hope you did great on it. So here is the lesson that we couldn't do in class, so I'm giving it to you online. So hopefully you do well with it. Okay, if you haven't already done so, pause this and go download the notes first. They should be at the bottom of the page of the Google site. All right, so we're going to talk about quadratic functions day one today, and we're going to begin discussing the parts of the parabola. So the three things that we need to know about the parts of any old parabola here is the vertex, the direction that it opens, and the axis of symmetry. So I have two parabolas over here on the right-hand side. All right, I have this blue parabola represented by f of x equals ax squared plus bx plus c. It's any old sort of quadratic function. And then I have this other one here, ax squared plus bx plus c. But the only difference is I've changed the a value. So the a value here is greater than 0, so positive values. And then the a value down here is negatives or negative values. And that does something to the graph, okay? So first let's talk about the vertex, all right? The vertex of the graph is either the highest point or the lowest point. So highest or the lowest. And if I was looking on the graph here, in this particular case, if my parabola opens upward, it's going to be the lowest point over here. And that's a vertex. Or in the other case, if my parabola opens down, it's going to be a high point over here. This is also called the vertex. So it's either going to be the highest or the lowest point depending on which direction the parabola opens. That leads me into talking about direction. All right. So there's two directions they can open. They can open up or they can open down in this case. They can also be sideways and slanted, but we're not going to get into that part just yet. So the way that you know that it opens up is if your a value, the part in front, this coefficient in front of your x squared term, is greater than 0 or positive, that's going to indicate it opens up. So we say a is greater than 0. If it opens down, then that means that your a value here has to be negative, or the coefficient in front of the x squared term will be negative, so a will be less than 0. So we have vertex, highest or lowest point, direction, either up or down. Axis of symmetry is that axis that goes right through the vertex. It'll always go right through the vertex. And that means that any point that is a certain distance away from the axis of symmetry on the left is guaranteed to be a certain distance away on the axis of symmetry on the right. That's the axis of symmetry part. So the important thing to know here is it passes through the vertex. So those are the parts of the parabola, right? The vertex, the direction, axis of symmetry. Got it? Perfect. All right, let's talk about standard form of the quadratic. So if I were going to sort of look at this parabola here, this quadratic, okay, we know from the previous chapter that this is a quadratic function of x squared. It's been moved 2 units to the left and then down 3 units. So I'm going to go ahead and graph that, and that's what we should see. A parabola, hopefully somewhere. There it is. Okay, so check it out. It is a parabola. It has been shifted 2 units to the left and then down 3 units, as we can tell by this graph here. Now that's pretty straightforward there. All right, and then if I were to graph this one, notice I have a negative out front, but then I have an x plus 2 squared and then minus a 3. Hopefully you know what that one's going to do. That's going to be a reflection, and notice it's going to be right there and heading downward. So there's something that's interesting here that's going on. If I asked you where the vertex was for this red graph, many of you would say, well, the vertex is at negative 2, 3. Negative 2, 3. I'm wondering if there is a negative 2, 3 anywhere in this little equation here that you can see. Likewise, is there one over here, a negative 2, negative 3, sorry. So does anyone see a negative 2, negative 3? You might be able to see it. That's important because that leads us into this idea, talking about the standard form for a quadratic. So the standard form is going to look something like this. F of x is equal to a times the quantity x minus h squared and then plus k. It's important to note here that a is not allowed to be 0 because if it was, we'd only have a constant term there. All right, so everything in here tells us something. So this tells us whether or not it's going to open up or down. It's going to open up if a is greater than 0. It's going to open down if a is less than 0. And then I also know where the vertex is because as we saw in this one, right, a negative 2 and a negative 3, there is something going on here with this form. So the vertex is going to be located at h, k. And you get those from right here, h and k. So the vertex is also hidden there. And the axis of symmetry, which I'll represent as AOS with periods in between, the axis of symmetry will always be the line x equals h. It's pretty sweet. Goes straight through there. So this is the standard form for a quadratic, and it tells you 3 things that you can look at. So it's a very useful form for us. All right, let's talk about how we would graph a quadratic in standard form. All right, we have 5 steps here. So the first step that we're going to do is we're going to figure out whether or not it opens up or down. And we do that by investigating the a value. So we look at that a value. If it's up, it goes a is positive, down if a is negative. The same thing we're going to do is we're going to get the vertex. And there's 2 ways that we're going to get it. I'm going to show you both ways later on. The third thing that we're going to do is we're going to get the x-intercept. Now remember, when we have an x-intercept, right, so x comma y, we always set the y-intercept to 0. So we set this equal to 0, and our x-intercept will be something. So I'm going to show you how that entails. And then our fourth thing is we're going to get the y-intercept. And remember, every single point for a y-intercept is an x and a y. But in this case, x's are always 0. So this is going to be the thing that we want. That's going to play a role for us. And then number 5, we're just going to plot some points. All right. So I should also mention that we can get, with the vertex, we also get the axis of symmetry. All right? So step 1, up or down, vertex, axis of symmetry, x-intercept, y-intercept, plot the points. That is how we graph a quadratic in standard form. Remember, standard form is this business up here. A x minus h squared plus k. All right, so let's try one of these here. F of x equals negative 2 times x minus 3 quantity all squared. All right, so step number 1, what do we got here? Does this open up or down? Hopefully you realize that this opens down because a is equal to negative 2. A value is equal to negative 2, so that means that a is less than 0. There's my a value right there. Definitely going to open down. Step number 2, get the vertex. Well, the vertex is located at h comma k. And since I have it in the correct form here, I can see the vertex is going to be located at 3, 8. So 3, 8. Notice the vertex is opposite the sign inside there, 8. So there's going to be our vertex. All right? And with this, I also get the axis of symmetry. The axis of symmetry is going to be the line x equals 3, as it says so right there. X equals 3. And we'll show you how that works when I graph this. All right, step number 3. I want to get the x-intercept. Now remember up here I said there's, the x-intercept, we're going to set the y equal to 0. So in this case, I'm going to set y, which is f of x, equal to 0, and then solve. So I'm going to say 0 is equal to negative 2, x minus 3 squared plus 8. So that means that negative 8 is equal to negative 2 times x minus 3 squared divided by negative 2. Looking good so far. So I'm getting 4 is equal to the quantity x minus 3 squared. I'm going to take the square root of both sides. So plus or minus 2 is equal to x minus 3. So it looks like I'm getting x is equal to 3 plus or minus 2. So I have 2 values for the x-intercepts. X got to be 3 plus 2, which would be 5, or 3 minus 2, which would be 1. So I have 2 x-intercepts there. All right. Step number 4, I want the y-intercept. Now remember, to get the y-intercept, check it out. We're going to set the x equal to 0. So in my original function here, my original parabola, I'm going to set the x equal to 0. So I'm going to have this. I'm going to have negative 2 times 0 minus 3 squared plus 8. So I'm going to evaluate what this is going to be. So I essentially want f of 0. All right, this looks like a negative 2 times a negative 3 squared plus 8. This is going to give me negative 2 times 9 plus 8. It's going to give me negative 18 plus 8. This is looking like negative 10. Great. So far I know the parabola opens down because a is negative. I know where the vertex is. I know where the x-symmetry is. I know where the x-intercepts are. And I even know where the y-intercept is. All I got to do now is graph this function. I'll graph this parabola. So here we go. I'm going to do my very best to graph this for you. Show you what it looks like. All right, so the vertex is at the point 3, 8. So I got to leave some room in there to get 3, 8 in there. And I'm going to graph this line over here. So, all right, to make everything fit on my graph, I had to go by a scale of 2s on the y-axis and a scale of 1s on the x-axis here. So I know the vertex is at the point 3, 8. So I'm going to go over 3 up 8. All right, and that means I also know that the axis of symmetry is the line x equals 3. So that's what I have here, x equals 3. And I know that I have two x-intercepts at 5 and at 1. So I'm going to go over to 5, x-intercept, 1, x-intercept. And I know the y-intercept is way down here at negative 10. So I have a y-intercept here at negative 10. So I got everything all on my graph. I know the parabola opens down. So all I got to do now is connect the points. And I have a nice looking parabola. And that is how we would graph it. All right, let's try another example together. Here we go. Let's do f of x equals x plus 3 quantity squared plus 1. Okay, step number 1. I know this opens up because a is a value of 1 and 1 is greater than 0. So a is positive in this case, so I know that the parabola is going to open up. Number 2, where's the vertex? The vertex is going to be at negative 3, 1. Remember, the vertex is at h, k is what we're calling it. Remember, it's opposite sides inside my parentheses. And that means that the axis of symmetry has to be the line x equals negative 3. Good, so far so good. Number 3, I'm going to get the x-intercepts. And I'm going to get the x-intercept by letting y equal 0. So essentially I'm going to say 0 is equal to x plus 3 squared plus 1. So negative 1 is equal to x plus 3 quantity squared. Take the square root, negative 1 equals x plus 3. Holy cow, I get an imaginary solution. What does that mean for us? That means for us, there is no real x-intercept. No real x-intercept because I'm getting an imaginary solution when I try and solve this. All right, what about the y-intercept? Is that the same story here? I don't know. Let's see here. For the y-intercept, I'm going to evaluate f of 0. So I want this to be 0 plus 3 quantity squared plus 1, which is just 3 squared plus 1, which is looking like 9 plus 1, which is looking like 10. Okay, good. So there are no x-intercepts, but there is a y-intercept. That is okay. Sometimes that is definitely the case. All right, I'm going to draw my graph. All right, I've got my table all set up. I've got my graph set up. The vertex is at negative 3, 1. So I'm going to go negative 3, 1. The axis of symmetry is the line x equals negative 3. So I'll go ahead and put that in with a dashed line here. There are no x-intercepts, and this opens up. So the only y-intercept I can put on the graph is the line 10. So if I am exactly 1, 2, 3 units to the right of my axis of symmetry, then I'm going to go 1, 2, 3 units to the left of my axis of symmetry. That point is also guaranteed to be on there. So my vertex was negative 3, 1, and I have these 2 points that I can actually use to draw the graph of my... All right, for the last idea here of the day, is I'm going to show you how to find the vertex of a quadratic that's in general form ax squared plus bx plus c. And I'm going to show you by way of an example. So let's say, I think this one's actually one of your homework problems. So let's say I give you f of x equals 2x squared minus 8x plus 3. And we want to find where the vertex is. There are 2 ways that you can do this. All right? I'm going to show you both ways, and you can pick whichever way you want. Doesn't matter to me. We already know that there's something useful about the form of having our standard form look like this. A times x minus h squared plus k. And the useful thing is that the vertex I can just read off as h comma k. So the question becomes then is how do we get from this form to this form? And the way that we do it is we complete the square. So this way I'm going to call completing the square way. The other way that we do it, I'm going to call it negative b over 2a, comma, f of negative b over 2a. Now, this way you're probably more familiar with. All right, so the first one, how do we complete the square on this? Well, let's work with this. So I have 2x squared minus 8x plus 3. And I'm trying to figure out where the vertex is. So I'm going to factor out a 2, give me x squared minus 4x, and then plus 3. Because after all, remember, I'm trying to make it look like this. I want this form out of it. All right, so now I'm going to complete the square. I'm going to get 2 times x squared minus 4x plus that magic number plus 3. Now, in order to keep my equation balanced, since I'm working on the same side, if I'm going to add a number there, then I need to subtract that same amount over here in order to keep my equation balanced. So I'm going to add and subtract the same number. I'm going to add and subtract the same amount to keep my equation balanced. So the question then is, okay, what number goes there? Well, I take half of negative 4, which is negative 2, and I square it and I get 4. Now you'd think a 4 would go here, but that's not necessarily true because check it out. We're actually taking 2 times a 4 and putting that number there, so 8 goes there because 2 times 4 is 8. Now, after you do that little bit of work, here's what you get. 2 times x minus 2 quantity squared, and then a minus 5. This is beautiful news because the vertex I can clearly see is at the point 2 comma negative 5. I think that's pretty slick. Let me show you another way to do this. All right. The other way is first figuring out, okay, the a value in my quadratic is 2, the b value in my quadratic is negative 8, and the c value in my quadratic is 3. That's the first thing I'm going to do. I want to figure out negative b over 2a. Notice that it has something to do with this value, right? Okay, so that means I'm going to have negative 8 all divided by 2 times 2. That gives me 8 divided by 4, which, oh my gosh, is 2. Check it out. Holy cow, matches the exact same thing. How is that possible? Math. Awesome. Okay, the other thing now, so far I figured out my vertex is at 2 comma something. I don't know what it is. How do I get this second part? Well, I take the 2 and I evaluate it. I plug it right back in. So I essentially take f of 2, which is 2 times, 2 squared minus 8 times 2 plus a 3. That's going to give me 2 times 4 minus 16 plus 3. This gives me 8 minus 16 plus a 3. This is going to give me a negative 5. Hey, look at that. Negative 5. So there's 2 ways that you can accomplish finding the vertex from a general form for a quadratic. You can either complete the square, keeping in mind that if you factor out a multiple of something, that's the correct multiple you have to add, and you can read it, or you can do negative b over 2a and evaluate f of negative b over 2a. Either way, you end up with the right vertex. All right, you guys, hope you had a great day.